Last lesson we looked at properties of linear relations, and we found that one of the properties they have is a constant rate of change. And that sounds complicated unless you think about it in another way, which is just there's a pattern. And we looked at a pattern in a table in y and x. We looked at a pattern in ordered pairs in y and x. And we saw that if there is a pattern, the points line up. And that's a linear relation. Well, we started off the unit by looking at this idea of water slides and wheelchair ramps. So quickly redraw the pictures that you had. So you drew pictures like this. And what I asked is, which would make the best water slide? And the best water slide would be the triangle that had a ratio of 5:1. And water slides are steep. Water slides allow you to go fast. So in picking one of these triangles, notice how we wrote it 5:1. 5 was the vertical dimension and 1 was the horizontal. So I just want to make note of that because that's going to be important as we move forward. Now, if I said, what's the best wheelchair ramp? Well, we don't want grandma flying down on her wheelchair, so we would pick the first triangle, the 1 to 5. And again, I want you to notice the vertical to horizontal meaning of the 1 and the 5. Well, again, as soon as you say, fast and slow is a rate of change. So we would be going fast down this water slide, and grandma would be going slow down that wheelchair ramp. So velocity and speed is a rate of change. You might think of it in terms of kilometers per hour, and we might come back to that later. But that's a rate. You're comparing two things. So we're going to change gears a teeny bit on rate of change, but there's a mathematical word for rate of change as a measure of steepness. And that's where we're going to spend a bit of time on the rest of the unit. So the steepness of a line depends on something. Think of this water slide, these water slides examples. The steepness of the line depends on the ratio of the vertical compared to the horizontal. So if you look at the 5 triangles above, then you're going to see that those numbers changed. And as we change those numbers, the steepness of the line changes. And again, if you started with the least steep, that would be a nice wheelchair ramp. And then as you made the vertical and horizontal distances different, then it got steeper. So if you change one dimension, then the steepness changes. And there's a mathematical word for this, and the word is slope. So the slope of a line can be thought of as the steepness of a line. And really what we need to understand is, well, what makes the slope change? What makes the steepness of a line different? So in order to determine the slope of the line, the steepness of the line, here's what we need to do. So the key thing right off the bat is to understand slope is a straight line words. Only lines have slope. Curves don't have slope. Circles don't have slope. So key idea number 1, understand that slope is a straight line word. And again, that's kind of redundant, right? Lines are straight. in order to determine the slope, well, we need to be able to figure out the vertical distance between 2 points and the horizontal distance between the same 2 points. Determine vertical distance. We can actually just count that. The vertical distance between any 2 points. So that's important. Any 2. And if we have a choice, well, we're gonna pick easy ones. Also determine the horizontal distance between the same 2 points. Between the same 2 points. So hopefully if we pick nice easy points, this is nice and easy to do. And then what we're going to do is we're going to compare them. And we're going to compare them as a fraction. Math people love numbers, and fractions are numbers. So again, I gave you an idea above about velocity, speed. So if we think of kilometers per hour, if we think of velocity, that always helps us remember the order that the order should go. So as with rates of change, last lesson, we can determine slope pictorially or using a table of values. And honestly, pictorially is the best way to go. So let's look at some mathy examples. And all I want to know is the slope. And there's no meaning to these stories. There's no distance. There's no gas being used like the examples above. Remember, this is our y-axis. This is our x-axis. Y is always vertical. X is always horizontal. And slope simply tells us the steepness of a line. And all we have to do is figure out the vertical distance between 2 points. So that's all I'm going to do. I'm going to figure out how far it is to go up to there and how far it is to go across there. So this will be my vertical distance and this will be my horizontal. And that's all I'm going to do in the other example as well. We're simply going to express the steepness of these lines as a number. And as we get more experience, the numbers will make more sense. So let's go ahead and do it. Now, it doesn't matter which point you start at, but like when we read, it's kind of a good habit to go left to right, just like when we read. So the coordinate of this point right here is -5, -5, and the coordinate of this point right here is 3, 3. And we're just going to go from this coordinate to this coordinate in a vertical and a horizontal direction. So how far do we go vertical? Well, in the vertical direction, I'll just call it V, we start at -5 and we go to +3. And in doing that, we actually go 8 spaces. Now you could count up 1, 2, 3, 4, 5, 6, 7, 8. There we are right there. The horizontal, we start at -5 and we also go to 3. And again, if you counted 1, 2, 3, 4, 5, 6, 7, 8. So we've counted our vertical distance, we've counted our horizontal distance between the 2 points, and now we're going to compare them. And we're going to compare them always vertical to horizontal, except we're going to express it as a fraction, a number. So when we simply go ahead and do this then, well, our vertical distance between 2 points is 8, our horizontal distance between 2 points is 8. So we could say the slope of that line, the steepness of that line, is 8 over 8, but 8 over 8 is also equal to 1 over 1, and 1 over 1 is also equal to 1. So all of these answers are acceptable, and what we would say is the slope of that line is 1. Okay, So we're simply calculating the slope, determining the slope of a line, nothing more. Well, in this one right here, if we started at this point, which is -5 comma 0, and we got to this point, which is 1 comma -4, we want to count the vertical and horizontal distances in between those 2 points. So the vertical distance, we're going to start at 0, and we're going to go to -4. And we end up going down 4. So that's what I literally did. I started at the top one, I went down to the lower one, I went down 4, and down is negative. So think up positive, down negative, right positive, left negative. So again, we have to differentiate between going up and down and left and right. In the horizontal, well, we started at -5 and we went to +1, and that meant we went 6 spaces. Now again, all you have to do is count it out on your grid. Draw those little arrows, draw the little triangle, and count it out. And when we actually put the numbers to determine slope as a rate, slope as a fraction, then we end up with vertical over horizontal. So the slope of that line is -4 over 6, and it's always a good idea to simplify -2 over 3. Now notice with the negative, I've tried to put it in front. I've actually tried not to put it with one of the numbers, and that's going to be important, as we're going to see in a sec. So that's simply how you determine the slope of a line. And based on these 2 examples above, what I want you to notice is, well, on one of the examples, the slope was positive. And on one of the answers, the slope was negative. And that becomes really important because the sign does something really simple but really important. The sign indicates the direction that the line goes. It either goes up from left to right or down from left to right. So here's a little bit more difficult one in that you don't have the picture, but it's the exact same question. So it's a really important idea to sketch a graph. If you're ever given an opportunity, always sketch the picture, and right away the picture will show you, is the slope positive or negative? So when you do your calculation, it's very obvious. So 2 comma 5 is right there, and -2, -8 is right there. And again, you use a ruler, but a ruler won't work on this thing. There's my straight line. And right away, that line is going up from left to right. So it better be a positive slope. But let's do our little triangle. First of all, we're going to go up to here. And again, you could imagine counting up or walking up, and we're going to go over there. So there's our vertical distance. There's our horizontal distance. And if you counted it, the vertical distance, we're going to start at -8, and we're going to go to +2, and we're going to go 10 in total. Or sorry, we're going to go -8 to 5. And we're going to go 13 in total. And our horizontal distance, we're going to start at -2, and we're going to go to +2, and we're going to go over 4. So that's this right here. There's our horizontal, we go over 4, and there's our vertical, we go up. So again, up is positive, +13, right is positive, +4. Therefore, the slope of that line, again, it's always vertical to horizontal, and math people want it as a fraction. It's going to be 13 over 4. So the steepness of that line is 13 over 4. Don't change it to a mixed number. This is the way we want to write it. We can't simplify it, so we'll just leave it alone. And again, I want you to notice that is positive. Okay, so let's do 4 quick calculations and summarize what we've done so far. So here are four quick things, four quick examples of what the slopes can be. In looking at AB, I hope you look at AB and you think, hey, that's got a positive slope. And if we figured it out, we would go up 2. So again, the slope of AB, I'm not going to put vertical to horizontal anymore. You might if you want. So in AB, we're going to go vertically 2, and we're going to go horizontally 6. So the slope of line AB is 2 over 6, or 1 over 3. And again, what I want you to notice, it's a positive slope. Okay, well, let's look at CD. Hopefully you look at CD and you go, it's a negative slope. And what I'm going to do is I'm going to go down 3, and I'm going to go right 5. So down 3, right 5. And again, technically that's right, but I want to rewrite this because I don't want to put the negative with one of the numbers. I want to put it out front because the negative actually indicates direction. So again, what I want you to see is that's a negative slope. Let's jump down to GH. And looking at the slope of that, I hope you would look at that and go, well, that has no slope. It's not steep, it's flat, right? So again, that might be a good word to make note of. Again, that's a flat line that has no slope. If you put a ball on that, the ball wouldn't roll. It wouldn't go anywhere. But let's look at our understanding of slope. It's the ratio of the change between vertical and horizontal. What's the vertical change between those 2 points, G and H? There's no vertical change, it's 0. And what's the horizontal change? Well, when I go left to right, I go plus 5. So the slope of that is 0 over 5. Maybe a better way of writing that is just 0. So that should make sense. There's no slope. And again, math people need a number. So that's that. Okay, finally the tricky one. And we're not going to run into this too often, but it's important to note. If I asked you to describe EF, how would you describe that? How steep is that? Is that really, really, really steep? So there's a problem. How do you put a number to it? So let's have a look at the vertical to horizontal discussion. If we started at F and went up, well, we would go up 4 spaces. There's our vertical. And how far did we go horizontally? Well, we didn't go anywhere. Now, math people have a problem with this thing, this 4 over 0. You can't divide 4 by 0. So the actual mathematical answer to this is a vertical line doesn't have no slope, because when you say no slope seems to be flat. No meaning none, meaning 0. This is actually undefined. We're not going to worry about that too much, but there it is. So here's what we have. We have this new word, slope, and we can simply figure out slope by finding the vertical and horizontal distance between 2 points. And the slope can be positive, negative, 0. Those are our main ones, are also undefined. We're going to spend one more lesson on slope, but then slope is going to be wrapped up in everything we do about lines. Slope is an important linear characteristic.